All right, time to start. Welcome to the introductory lecture in object-oriented analysis and design using UML. And now I think everything should be up and running. For you guys that are online and watching the stream, ask any questions or post problems in the chat, and someone here on campus will alert me to it, or maybe I will see it myself. Today we are primarily going to take a look at the course structure, what is required from you, where you find the material, and how the material is presented and divided, what you need to do to get a final grade in the course, and how the grading will be done, and so on and so forth. We will also do a micro introduction to the subject area itself also, namely object-oriented analysis and design. But we will start with the course structure. And let me know if you have any questions. You can ask them in Swedish or in English. So I will try to answer at the best of my abilities. So first things first, it's good to become registered for the course if you are supposed to attend it. So if you have not managed to register yet for some reason, there is a form for you to fill out on the course homepage in CoursePress, and click course registration there. So there is a lot of different students on this course. We have kind of like all the computer science programs that attend it. So it's a bunch of students from Växjö, it's a bunch of students here from Kalmar, and we have a bunch of students online. And we also have international students and students from other universities just taking this as a free course. So regarding that, it's natural that there will be a lot of different types of backgrounds for you guys, and the admissions is quite square in their admissions process. So they have kind of like these courses that you must have, and they are not very flexible regarding that. So there is a high possibility that you can attend the course, but you cannot do the normal registration process. Yeah, good. Yes, if you have registered on LNU SE student, everything is fine. You don't need to do anything. But if you, for some reason, couldn't register there, there is this form that you fill in on the course homepage, and you basically state your name and your personal number and email address if you study a program. If you are an old student and just want to be registered in MyMoodle or added to the MyMoodle page of the course to be able to hand in assignments, then it's a simple process. You just state this here. And you state what you think the problem is. Maybe you have some credits that are incoming, or you have some other object-oriented programming course. I will take a look at this tomorrow afternoon. So you need to fill this out before 2 o'clock tomorrow. I think I set the deadline to. And I will send it to the administrators tomorrow afternoon, and hopefully you will be registered for the course in a few days. I will contact you if there's any problem in this area, and we can discuss this via email. So let's take a look at the requirements for the course. Then you need to have something like 30 credits in computer science, computer technology, informatics, media technology, or something like that. I'm pretty easygoing on this. For example, I usually count the math for computer science courses into this bunch of credits. Maybe more importantly, you need to have a good, strong background in object-oriented programming. So a good chunk of credits in object-oriented programming is required. No, you don't need to resupply your info in the form if you added some other email address. You can add any email address there. So that's for kind of like the prerequisites. And the programming part is because there's a lot of programming in this course. Even though it's an analysis and design course, you will need to implement a lot of stuff, and you need to read code, translate it into models, look at models, and translate those into code. So the coding part cannot be the problem for you here. And if you have not coded anything during the summer, get back at it as soon as possible. Start looking at your old assignments, start doing some small project, do something, get into the habit of coding and get the feeling for the code again. Yes? You may use any language. I recommend something typed, strongly typed, like Java or C#, and of course something object-oriented. That will make life a lot easier for you. But the course itself is quite language agnostic. The lectures are double lectures, so to speak. One version, I did the course using Java for the examples, and 1 year I did it with C# for the examples. So if you want to be more easily able to follow the course, maybe C# or Java is the best strategy. But any language is okay. And if you want to try something new, spend a little more time doing that, it's fine. Good question. So when you have registered, you should, of course, try to get the course literature. And we use a book called Applying UML and Patterns by Craig Larman. You can see here there's quite a lot of chapters that are vital in the course. And there are some chapters that are not so vital, but maybe good to at least skim through to get the whole picture, so to speak. For example, I think this chapter 2, there's a huge use case example. Maybe you don't need to read that in detail, but it could be good to just take a quick look at it to understand what happens in the following chapters in the book. He uses 3 examples in the book throughout its contents. There's a monopoly game, a point of sale system, and a persistence framework. These examples are actually really good. In the book he uses Java, but it's quite similar also to C#, so it shouldn't be a big problem. But I think those examples are really good in the book, so take a look at those. In the course, I think the lectures use 2 examples, one small dice game and one a little bit larger card game. So you will kind of like get 5 opportunities to see examples of analysis, design, and code, and how these kind of like match with each other if you study the book also. So I think you should get a hold of the book. And you can also see the chapters that are in focus for each of the assignments or workshops. One thing about the book is that it's maybe a little bit strangely laid out. So it's iteratively laid out. That means that he takes a subject and then he talks a little bit about it. Then he takes another subject and talks a little bit about that, and maybe a third subject and talks a little bit about that. Then he reiterates and talks a little bit deeper about the first subject, deeper about the second, and so on and so forth. So it's this iterative approach to learning this stuff. There could be good points in doing this. Sometimes you would like to kind of like read everything about one subject matter in kind of like sequence, and the lectures that we have in this course are more built like that. So let's take a look at the lectures. Maybe we should start with this kind of like domain modeling lecture. That is maybe the first one you will see. And you can see this then because of the reading instructions in this for this lecture. It's chapter 9 and chapter 31. So to get a whole concept, you need to kind of like jump in the book. So the lectures are built up like this. There's what you will learn. There are some reading instructions. There are additional materials, my slides that I use in the lecture, maybe some additional materials also that are used as an example. And then you have the recorded lectures. So now I don't remember which year is Java and which is C#. But basically you have the one version first and then the second version next. And maybe even older lectures for this stuff. Basically, I say the same things in these lectures, but if you have a hard time understanding something or grasping something, it could be worth checking the other year's lecture out also and try to find that portion of the lecture that you had a hard time understanding. There are some chance that you will get a slightly different angle on something that maybe is more easy for you to understand. So all the lectures are recorded. You study these yourself. There are no more lectures in the classroom. So basically you will meet me in tutoring sessions. Either we can meet in a classroom here, or we can do this online. It's up to you, more or less, what you would like to do. But using my Moodle, you will be able to book tutoring sessions, and there we can talk about the course material, lectures, or the assignments. It's more or less up to you. The reason for this is that, well, lectures are nice and good and everything, but the retention is not that high for students. You don't really learn stuff by attending lectures that much. You learn more by trying out things and maybe discussing with someone when you have a problem or when you would like to know more. And quite frankly, there weren't many students that attended the lectures the last time I did them, like 4 or 5 students. So it wasn't really worth it. So all the lectures are recorded and you can study them at your own pace. I wholeheartedly recommend that you have the auto translation on and try to find the funniest wrong translation that Google has made. It's always interesting. So that's it for the theory. So when the course approaches the end, we will of course have some kind of examination. The examination for the theoretical part is an online test that you will do, and you will fill in a number of, answer a number of questions. It's multiple choice questions. If you answer everything right, you will get a credit. If you answer anything wrong, you will get 0. But you will have a chance to motivate why you answered the way you did for every question that you answered wrong. And hopefully I will award you a bonus point for your great motivations. This online test will, you will have 3 opportunities in this period to pass the exam. The 17th of October, the 25th, and the 2nd of November. And the test is time limited, so I think it's like half an hour or 45 minutes or something like that. And you have this time span to do the test. Later on, we will have another bunch of tests, either in kind of like before Christmas or after Christmas, depending a little bit on what you want. But take the opportunity to try to pass this as soon as possible, of course. So this test is done individually, and you will get a pass-fail for this. The test itself is worth 1 credit in LODOC. So when you have passed the test, you will get 1 credit. The remainder of the course is examined using assignments, or I call them workshops, but they are really assignments. So let's take a look at those. When this course started, like maybe 10 years ago, something like that, the class was kind of like this big, 25, 30 people. We could do like workshops at campus, and I could go around to between groups and stuff like that. The course has grown. Everyone is attending it. We have like probably up to 150 to 200 students attending it right now, I think. So this is infeasible at this scale. So it's more like traditional assignments that you have done before. Maybe the only difference is that you are allowed to work in small groups. So you can work in small groups with up to 3 people, but no more. If you are 4 friends that would like to work together, then you make 2 groups. The reason for this is that the aspect of communication and being able to work together is important in analysis and design, and hardly something that you would do in real life for your own only. It's probably something that you would do in a group setting anyway, and it's good to get some practice doing this also. That being said, I would like, as I said, the groups to be small, and I would like for everyone to participate in all aspects of each assignment, so you don't divide the work as much. And I also think that maybe it's a little bit hard in these assignments that you do. So we have group work for the assignments allowed, and you will also do peer reviewing. So for the first 2 workshops, you will send in your materials to a system, and you will take a look at other groups' work and critique them. And you will receive critique also from other groups. We will talk a little bit more about that later. And maybe thirdly, you will get an example solution also for the assignments. So when the final deadline has passed for the passing grades, then I will show you my example solution with some text and discussion about how what I thought about this assignment and how I think it should be approached. So basically you will have several opportunities to work with the assignments, get critique on them, look at other solutions, see what's good in them, what's bad in them, and enhance your retention and your learning from this, hopefully. But especially for the peer reviewing, it's important that you do take this seriously and really try to give good critique to your classmates. All right. Then let's take a look at the peer reviewing process.
Fråga.
Yes.
Ska vi ge kritik bara till folk i vår klass eller till alla som deltar i kurser?
The critique is done anonymously, so you will not know who you will get, and you can get any other group. So maybe you will get a solution in a very exotic language that you have never seen before, if you're lucky. So that's one of the caveats maybe with this selection of language. Though the programming part should not be that problematic to at least get a basic understanding of in kind of like every language. They are quite similar. So it's a good question. You can get anyone. Anyone that submits anything to this. Yes? Yeah. English is best to use. It would be nice maybe to have an option kind of like in this system to take to say that you have written in Swedish or something like that, but go for English is the best option. All right, peer reviewing. So when you have done some work in the assignment, maybe you haven't done all of it, but a big bulk of work, it's always better to send in what you have than to not send in even if you think you're not finished. Then you can state that in your submission. We didn't have time to do this, or we missed that part, or something like that. You will send in the work in this system, and after a deadline, you will be able to make the reviews that you are supposed to do. And in this system, you will get instructions on what to look for, what to try to critique in different parts. So take your time doing this and try to do good reviews. One important aspect is that if you work in a group, every member of the group should upload exactly the same file. Otherwise, there is a slight chance that you will kind of like review your teammates' work. So upload the exact same file. You are required to do at least two reviews, but you can do more if you want to. Some students find this quite nice and rewarding, so they kind of like do 11 reviews. So it's a good way to see, for you to see more examples on how someone else thought about this problem and how they tried to solve it. Maybe they did something good, maybe they did something that you think is bad. Then you can give that feedback back to them, and you will also receive feedback on your solution. Since it's peer reviewing, it's not 100% certain that the critique you get is valid. So you need to think about the critique you get also and investigate further if it's a valid and good critique, or maybe the reviewer has misunderstood something. This also means that you need to study the theory, the book, and the lectures so that you can give good and valid critique. And one thing to really remember here is that I will also take a look. You will also give a grade on the reviews that you receive. So if you receive very poorly written critique, or maybe just everything looks good, then maybe you should give that reviewer a bad score, and then I will take a look at the review, and I can maybe even fail that reviewer for this workshop. So take the reviewing seriously and do your best. There is also no way to make an extra assignment or do something extra if you miss this in some way. So if you miss the peer review part, there is no chance for you to pass the workshop, the assignment. All right? Don't miss it. Do your best. So there are some instructions here that you can take a better look at. So when you have done the assignments and the peer reviewing, maybe we should take a look at the deadlines. So this will explain a little bit. So for the workshop 1, you have a passing grade submission to peer review. So Monday, September 16, you must submit something into the peer review system so that we can start peer reviewing. You must submit your reviews by Thursday, September 19. So you have like 3 days to do at least 2 reviews. And finally, you submit your final solution in My Moodle on Thursday, September 26. So you have some time to react to the feedback, improve your work even more. Maybe you didn't finish everything for the passing grade for the peer review stuff. Maybe you need to do something more also. So that's how it will work. And if you're really conscious here, you see passing grade. This also means that if you want higher grade in the course, you can continue working on your workshops and you make the higher grade submission towards the end of the course. And you can also switch groups for the higher grade. So maybe not everyone in your group wants to continue working for the higher grade. Maybe you can find some other teammate to work with for the higher grades. You also don't need to stick to the groups between the workshops. So you can find someone else to work with if you want to, or maybe you work solo for the first one and then you want to be in a group for the second one, then solo for the third one. That's also fine. You manage this all by yourselves, but when you make the final submission, everyone in the group must make a submission, and you must state clearly in the submission who you have worked with, so we can easily find it. Okay, questions? Total confusion? I think things will kind of like, we have had this system for some years now. It has worked, not flawlessly maybe, but fairly okay. Previous years, so I think it will run fine this year also. So let's take a short look at maybe the assignments then. So the first workshop or assignment is about domain modeling. There are some instructions here. Basically, you have some requirements that you need to take care of for the passing grade. This is what you should submit into the peer review system. There's a problem description that you should take into consideration, and there are some requirements in the form of different use cases. And for the passing grade, you have a number of these: 4, 5, 6, 8, 10, 11, and 12. And if you want the grade 3, then you do everything for grade 2, of course, and then you extend it so it includes all the requirements in the problem description. And the requirement, if you want to do grade 4, is to make a comprehensive domain model for any of the following. For example, an online media or bookstore, an e-commerce site for computer stuff, a library, a fast food restaurant, or something that you come up with yourself. But contact me then, and I can say if it's a good idea or a bad idea. Libraries are particularly popular, I can tell you. Librarians are often quite easy to talk to, and they are often quite interested in talking about library stuff. So if you select a library, there's a high chance that you can actually talk to a librarian, and they will explain how a library works in some way. That's at least my impression. So there's almost always someone that does a domain model for a library each year. And this kind of like stuff is repeated. So workshop number 2 is about design. So I think it's a small membership registry for a boat club, and you are supposed to be able to do some stuff in this. For example, you are supposed to be able to create a new member with some information. You're supposed to be able to list all the members in 2 different ways, delete the member, and so on and so forth. And you have some more requirements for grade 3. For example, you should have some authentication here, logged in or not logged in, and different functions should work if you're logged in, and others should work if you're not logged in. And some kind of a search and selection of members. And finally, for grade 4, there's a little bit more to do. So basically, you can select the level of commitment that you want to do in this course. So you do the passing grade first, and then you opt in on higher grades. And of course, it's kind of like, it's kind of like the same for this third one. Then we do design using patterns, and you get some code that you are supposed to extend in different ways. And of course, there's a list of requirements for grade 2, and for grade 3, and for grade 4. So at the end of the course, when you have passed everything, you should be able to plug in your values into this matrix and get a final grade for the course. So for example, I passed the exam. I did workshop 1 for level 3, workshop 2 for level 4, and workshop 2 for level 3 for level 2. And then I will get a B. And if you look at this matrix carefully, there are probably some opportunities for gaming it. For example, if I've done this for number 4 and that for number 4, I really don't need to do number 4 for workshop number 3 to get the highest grade. So you can optimize things here also if you want to. But go for the passing grade first and then opt in on the higher grades. And higher grade submissions are done at the end of the course. So you have time to improve. And you can also take my suggested solution, for example, for workshop number 2 and continue working on that code instead of your own, if you want to. All right. You will also get a grade for each of the workshops in LADOC, and that's straightly just a conversion. If you do for 2 passing grade, you get an E. If you do 3, you will get a C. And if you do 4, you will get an A on each of the assignments. All right, any questions here? Nothing? Nice. So what happens if you, for some reason, don't participate in the workshop or miss the peer review for some reason or something like that? Then there is an extra assignment for you. And it's a Yahtzee game. And depending on what you have missed, what workshop you have missed, you do this game at different kind of like levels. So if you miss workshop number 1 for some reason, then you do a domain model for the Yahtzee game. If you miss workshop number 1 and number 2, then you do a domain model and you do a design and you take a look at the requirements for grade number 2 in the assignment, and you make a good choice of requirements from kind of like this list and select those that apply to this kind of like workshop that you missed. And you take a look at kind of like what diagrams do I need to submit for workshop number 2. I think it's like a class diagram and 2 interaction diagrams or something like that, and then you submit that also. And the same thing if you miss workshop number 3, then you need to do some designing here and do something with patterns also in this game. And if you kind of like submit something for the peer review, and you submit something in the final deadline, but for some reason it's not complete or it's not good enough or something like that, you will have one chance to make complementary changes for it. And if you miss the complementary changes for some reason, you need to do the Yahtzee game. So you cannot submit the same stuff over and over and over and over and over and over again. Right? The easiest way to pass the course is, of course, to participate in the course as it's presented, do the peer reviewing, submit stuff, and take the complementing seriously if you get to that part. But hopefully everyone should be able to pass this course quite, maybe not easily, but with some work. Maybe the biggest, okay, let's talk a little bit about time in the workshops. I think the first workshop is actually much easier than you think. You read this and you will think it's super advanced and stuff that you, it's really hard or something like that. But it's actually quite small and quite easy. So don't go overboard when you read this. Take a look at the book and the lectures. They quite clearly describe what you need to do and how you should think. And book tutoring sessions if you get stuck or have no idea on how to progress. Of course, as it's the first kind of like workshop, it will feel, or assignment, it will feel a little bit awkward. Everything is a little bit new and stuff like that. So for that reason, you should not underestimate it and start early on it for that sake. But it's not particularly big. It's not particularly advanced. However, the second workshop, that one is by far the most time-consuming one. This workshop requires you to design and implement something from scratch. And while it's not a big system, you will have at least 3, 4, 5 different classes with code in them. And maybe the programming is, well, not super tough, but it's a lot to do. And getting stuff to work is always a little bit problematic. So don't underestimate the amount of time that you need to spend on the second workshop. It's not particularly advanced, but it will require some time. The third workshop is often seen right now as the most advanced one. So you will extend a blackjack game here, and the code you get looks something like this. So there's a number of classes, there's a number of packages, there's a number of interfaces, and these are something that you should extend using different design patterns. And maybe this looks overwhelming and strange right now, but when you get to this, and if you have followed the theory in the course, it will be not that much work. It's quite a low amount of code that you need to write to extend this stuff. So it's not super tough or super big, but it's a little bit advanced. So you need to kind of like have the design and design patterns. You need to know what that is to be able to finish this. All right, so first workshop, easy to go a little bit overboard with it. So try to keep it small and simple. That's often better. The second workshop, don't underestimate the time that you need, because it's quite a lot of programming in it. The third workshop looks maybe a little bit advanced, but it's actually not that much work to be done in it, if you know the design patterns and if you know the programming. And also for the third workshop, many of the lectures kind of like build this foundation code. So if you take a look at the lectures, you will see how we have built the code that you get for the workshop. So it's not something completely new for you to take a look at. So the lectures are building this blackjack game, at least the kind of like the latter lectures. All right. Another thing to take a look at is that we do quite a lot of coding in the lectures. So there's quite a lot of programming in them. And this code is, of course, available to you on GitHub. So, for example, we do this dice game kind of like first here. And you see that there are a lot of different languages represented here. And those are not done by me. They are done by other students. And I think the C# one and the Java one are done by me, and other students have committed the other ones. So if you have some language that you think is missing, maybe just for fun or as an exercise for yourself, feel free to contribute. I will take a look at it, and I will hopefully just add it to this list. It's a nice way to get to know a few other languages. And if we, for example, take a look at the Swift code here, it doesn't really look that much different from, for example, C# or Java. So it's a good, nice way to get a feeling for some other languages and see how the same design is translated or mapped to different types of programming languages and different codes. Is an interesting aspect of the course also. So feel free to contribute. And as I said, the course itself is language agnostic. For the final assignment there, you will get code in either C# or Java. So if you select something else, then you need to make a translation of what's already there. A little bit more work, but maybe something that's worth it if you want to do this in another language. All right. Did I miss something? We use Slack, of course, as the main communication channel. So ask questions in Slack first in the channel. Hopefully I will answer. Maybe someone else will answer before me. I'm usually quite fast at answering, but you never know. So let's help each other out and try to answer questions as soon as possible. And there might be programming problems, or maybe you do this in some exotic language and need some help with that. Maybe someone else knows how to do the stuff that you need to do. Feel free to ask in the Slack channel. Submissions are handled using MyMoodle as usual. Make sure that everyone in the group submits and that you state who has worked together in the submission. That is to make it easier for the grading and the feedback that you will receive. So I think maybe this is it. Yeah, maybe we should just kind of like take a look at the course management. It's easy to forget. So I'm the course coordinator, I'm the examiner and lecturer, and I will be tutoring here on campus and online. If you would like to meet me, you can step into my office or knock on the door if it's closed. Hopefully I will hear you. Or contact me on Slack and we can set up a tutoring session or something like that. And feel free also to wish for times for the tutoring sessions. I will base this at first on my own schedule and do what's convenient for me, and maybe that's not at all convenient for you. There's, as I said, a lot of different students, so it's quite impossible to make everyone happy, but hopefully everyone will get the opportunity, at least somewhere, to get tutoring in a good time. So if you want to meet at campus, we can book a room and do the tutoring. If you want to meet online, we will use Slack channels dedicated for that specifically. But book this in MyMoodle, so you will have time slots there that you can select on. And the idea is to meet with one or a few groups each session. So you will be a small group either online or on campus. We will discuss your questions and problems, and you will hear the discussion for the other group and can also chip in on that. So you can regard it as some kind of like mini on-demand lectures for the topics that you think are worth spending time on or the questions that you have. So if you have any special times that works better for you, post them in Slack. Maybe there are more students that would like these times also, so then we can get a good scheduling for the tutoring sessions. All right. There is one caveat for this, and that is that I will go to Paris for a conference on Friday, and I will be back next Friday. So I will be gone for a week. During this time, I will try to answer stuff in Slack as soon as possible, but there is a higher chance that I will be unavailable during this time. So bear that in mind. but I will be back with a vengeance after 1 week. So then we can fully focus on this course. And the reason for me to go to Paris is because I'm also a PhD student. So I need to go to different conferences and present my work and get feedback from peers on that. So I will attend a workshop called Saerocon on software architecture, erosion and conformance checking, and the European Conference on Software Architecture, EXA. So hopefully I will learn something during this time also. All right, I think someone is typing something in the Slack channel. I have some unread mention here also. I will take care about that during the recess, but maybe there's a question coming. No? All right, I think the level of oxygen here is quite low now. So let's take 15 minutes of a break, and we will take a look at the what object orientation is, and what analysis and design is, and what the UML is, in some kind of a mini overview after 15 minutes. All right, see you later. 15 minutes of a break. All right. Think it's time to start. The stream seems to be working. So, if we think back a little bit, you had the course 1DV600, and using that course we can kind of like place analysis and design into a context. So basically, what do you need to do first when developing something? Any ideas? What would you like to do?
Analysera.
Yeah, sure, analyze. So what is doing analysis really about? Yeah?
Case study.
Yeah, you can do a case study, and the aim of the case study, what is that? Yes?
Requirements.
Yeah, requirements are good, but oh yeah, sure. But basically we do all that stuff to be able to understand the problem, right? We need to know what it is we are supposed to do. You probably like coding, at least to some extent, but before coding you need to understand what to code, right? Hacking away at the keyboard, doing random statements, well, it may be fun, but it will probably not solve any problem. So we need to understand what it is we are supposed to do, what the problem is. As a student, you often face quite not simple problems, but easy to understand problems. So we don't spend a lot of time understanding the problem itself. And that's because it takes often a lot of time to understand at least complicated problems. Like banking systems, they are very complicated. Car control systems are super complicated. But rather, as students, you kind of like face quite easy to understand problems. For example, in Växjö, they had a project, and the project was about doing an e-commerce system. From a problem kind of a standpoint, it's quite an easy problem to understand. You have used e-commerce systems, all of you, probably before. You know how to add stuff to your shopping basket and do the checkout and stuff like that. You know kind of like how this is supposed to work and feel. So you often encounter quite simple or easy problems, easy to understand problems. And that's because we kind of like need to move on quite rapidly. So when you have understood the problem, or at least part of the problem, what happens next? You need to get some kind of idea on how to solve this problem. We will solve it by doing a web-based system using this framework, right? We will use this programming language, or we will solve the problem using this technique or this technology or something like that. So we need to do something to understand how to solve the problem. What is the problem? How to solve it? Then we can solve it, or try to solve it. So we can do stuff, and finally we should test that we actually solved the problem. So this is basically a development process. We need to understand what, we need to understand how, we need to do it, and we need to check. And maybe the courses that you have had previously, especially those in programming, has kind of like focused on the doing stuff. You have gotten quite well presented problems with requirements already done. You have the how is probably quite easy. You have had a programming language already selected. Maybe you only need to do a few functions to solve the problem. And checking, well, students are notoriously bad at checking their stuff. That's why we have tutors and we do the final examination, and there's almost always something that is problematic. So the courses you have had previously have maybe focused on the doing. In this course, we will focus on the what and the how. How to understand problems, how to understand what to do, how to design so that the doing becomes as easy or the way that we would like to have it. Checking will be done in upcoming courses in testing. So with our words, we kind of like call this requirements and analysis, design, implement, and test. And kind of like this stuff is something that you can do in different ways. If you remember back to the 1DV600 course, you could do this in like a waterfall model. You try to understand every aspect of what to do, what the problem is. You try to design something that completely solves this problem. Then you implement this design, and finally you test it. A natural way of working maybe works quite well in stable environments when the requirements are not changing rapidly, when techniques and technologies are not changing rapidly. Then you can opt for a more waterfall-like process. If you have very volatile requirements, if you have a volatile environment, then you probably cannot spend too much time on requirements analysis, design, implementation before actually testing if stuff works, or if the users are satisfied, or if there's something else that has come up. Then you need to rapidly do this over and over iteratively. You can do this in an agile way, that is, try to eliminate as much waste as possible. Try to get by with sketches instead of blueprints. Maybe on a whiteboard instead of in a fancy tool that's saved and needs to be maintained. And all of this is very up to the environment that you have. Maybe you are 500 people scattered on multiple sites, different countries. Then it's probably more likely that you need more of a stable design before everyone can implement their stuff without accidents happening. Everyone cannot just run around and do everything everywhere. You need to have some basic division of stuff. Maybe you need more of a blueprint then. If you are 2 to 3 people sitting in the same room, sketches on a whiteboard will probably suffice. So it's more or less just a matter of scale and level of detail here. But you always do this. You always do the what do, how do, and check. Even if it's just up in your head. Design is not something that is necessarily done on a piece of paper, in a tool, or on a whiteboard. You can do it in your head also. And actually you almost always do that, but maybe you don't think about it. So this course focuses, of course, then on analysis and design, on how to understand problems and how to solve problems so that we later can implement the solutions that we have seen. However, we can also do this the other way around. So we can kind of like start with testing and with code first, and then when looking at the code, we can find opportunities to refine our design. So we can do refactoring instead of designing first. We can do design afterwards to make things simpler and less complicated. And that is also something that is part of this course. Looking at an implementation, realizing stuff that's too complicated or bad from some perspective, finding a solution for it, and doing the design work after we have an implementation. So it's not necessarily so that you have the ultimate design before implementing, rather the opposite. You will find the ultimate design by constantly looking at the design level, the implementation level, and going back and forth. All right? And we will use object orientation in this course. Maybe you remember that objects are kind of like information and behavior packaged in one kind of like entity, and we call this an object. This is supposed to be an analogy to the real world, to some either complicated system or just the real world as we see it. But it's always kind of like some form of abstraction. We cannot model the world as it's infinitely complicated. We need to make some kind of a judgment on what to include and what to leave out, what level of detail we want to have and what we don't need to have. We try to encapsulate information and behavior in these objects. We can build different types of hierarchies, so we can assemble more complicated objects out of less complicated objects. We can imagine a car, for example. Just looking at one part is really, really complicated. The fuel exhaust system is not something that you can really understand easily. But we can build different types of cars combining different types of objects. And they will get different kinds of performance and so on and so forth. So that's composition or whole part hierarchies. We also understand problems by doing this kind of like is-a hierarchies. So we can understand that there are different types of trees, but we can understand the concept of a tree at some abstract level. It has leaves and it has branches, it has roots and bark and stuff like that. And kind of like every tree that we encounter has these parts. And this is quite an interesting aspect out of how we as humans kind of like abstract our reality. We don't really see the details. We kind of like just filter everything and make them abstract so that we can cope with our everyday lives. We don't really see the details in our very complicated environment. In object orientation, polymorphism or overloading of methods is an important technique so that we can add special behavior to special parts of our program without the need to rewrite everything. And basically we use object orientation because it's a coherent way, a single way to think about the what, the how, and the do. So it's easier to understand the code because we can understand the reality, and they kind of like match in some respects. We will use the unified modeling language simply because it's a standardized language to do this. Boxes and arrows, not that complicated. It's a visual language. We're quite good as humans at processing visual images. Kind of like understanding the structure of a system is quite hard to do when only looking at code. Looking at kind of like the boxes and arrows between these boxes immediately conveys us some information. It's important to note that the UML is not a process, it's a language. You can use UML in every kind of a process that you have. And it's actually also more than object orientation. You probably did some state charts in 1DV600 that are also defined in UML, but are not necessarily object oriented. Right? So, a small mini example. We have a requirement, play dice game. It simply states that the dice are rolled and the result is presented. If the sum is 7, the player wins. So, anyone knows any central concept in this small requirement? What's kind of like the most central part here? Anyone?
The dice.
Dice, exactly. It's a dice game. The dice are rolled. Chances are that we are looking at the problem that involves dice. So, how many dice do we have? Yeah?
2.
2? Why?
Because it's more than 6.
It's more than 6, but how many values does the dice have?
It's the same.
6-sided? Maybe. Could be 10-sided dice. Could be some other kind of weird dice, right? I guess like 90% of you thought about 2 dices, 6 sides per dice, right? You assumed that this was the case. And this is an important aspect of analysis. Taking a requirement, creating a model based on the central entities or classes, and finding flaws in the requirements or missing information becomes often a little bit easier. So we found out that we had a dice. We probably have a dice game that rolls these or contains these dices. But we didn't know actually if it was 2 dices, 500. We did not know what the value span was for these. So this is something that we can discover when we do the domain model, and we can hopefully not assume, because if you assume things, they will probably not be correct. So we can go back to the user or the one that wrote the requirement and ask them. Or maybe we have like 500 requirements, and somewhere in these 500 requirements, this is stated. But we can make an analysis model out of this, and we can specify. We can more clearly see that this is not stated in the requirement. We need to find this. Maybe we find it somewhere else, or maybe we need to ask someone. Assuming things is probably not a good idea. But assumptions are very much made automatically. It's hard to know, really, that you assume and when you're not assuming. So making this kind of a model can help you not assume stuff that you kind of like get in your head just by reading this little requirement. And moving on from this analysis model, we can move on to design, and we can take a look at interaction between objects. And we can see that we have a dice game object, and we want to play the dice game. And when playing the dice game, we roll the first dice and we roll the second dice. We get the value from the first one, we get the value from the second one. We can do the win-lose computation and return some Boolean value, for example. And for the class diagram, it would look something like this. So we have the dice game class. It has the operation play that returns a Boolean value. It has 2 fields. Are they called fields in C#? Member variables. Do you remember? Properties, right. They are called fields in Java. So in UML, we call them, in this case, they are associations. The dice has a value attribute. It's an integer. It has a value span of 1 to 6. It has a roll operation. It has the get value operation that returns an integer. And as you can see, we kind of like keep the vocabulary here. It's not called something else than dice and dice game suddenly. We keep the kind of like the flow of the requirement in this more dynamic interaction diagram here. We roll and we get values and stuff like that, and we play all stuff that's actually also in the requirement, in the real world example here. And this is for us to be able to more easily grasp the problem, understand how to solve it, and then the implementation, in this case, will be quite straightforward, and the implementation will also keep these words in it, and it will be, as a whole, easier to understand this system. So this is basically what you will do in the assignments. So you will learn how to do analysis models, and you will try to do one for the first assignment. In the second assignment, you will do a design model that's this exact kind of diagrams, class diagram and interaction diagram. And you will do implementation of what you designed. And if the implementation deviates from the design, you will update your design so it reflects the actual implementation that you have done. And the third workshop will be about doing design in using particular ways of structuring your classes to get more systems that are easier to evolve, reuse, and divide among several different programmers, for example. All right? Questions? Everything is totally clear? Great. I think this is it for this small introductory part of the course. If you have any questions beyond this, ask them in Slack. I will answer them as soon as possible. Start working on the theory and the first workshop as soon as possible. If you're not registered yet, do that or fill in the form and I will take a look at it. Otherwise, see you in the tutoring sessions. All right? Bye-bye.